degree of multiprogramming, but we observe that the partitions in which the process the jobs J1, J2, J3 are sitting, they are different. Okay. So in first fit, J1 was sitting here, but in worst fit Jn is sitting here. Okay. Now we'll extend this question for another algorithms called next fit and also best fit. Okay. We'll find what is next fit and best fit in this algorithm. Okay. And what is the degree of multiprogramming, we'll see. So here total internal fragmentation. Total is total internal fragmentation, which is 180 plus 20, which leaves in 200 kilobytes, and which is total internal fragmentation, and total external fragmentation is here 16. Job is not used, 16 kilobyte is not used, so 16 doesn't use. So total fragmentation is 200 plus 16 is equal to 216, which is equivalent to same as first fit algorithm. The thing is, the process has been allocated in the same partitions, but different jobs are sitting in that partitions. That is the difference we saw here. Okay. Now let's see what is next fit. In order to run the algorithm next fit, we should know what is the last allocated block. If we assume that the last allocated, initially the last allocated block is nothing. Okay, it will be starting from beginning. Okay, now let's start. Okay, so next fit also works same as first fit, but the process is it will start not from the beginning, but it will start looking for partitions from the point where it has allocated the previous block. So when job J1 comes, so condition is satisfied, job 1 will sit here. So in partition P1, when job sits, then the internal fragmentation will be 30 minus 20, which is 10 kilobytes. When job J2 comes, when job J2 comes, what happens here? J2 again will be allocated here, because the condition is satisfied. So 200 minus 30 gives 170 kilobytes. Now here, this will be the last allocated block, but now this will be the last allocated block. Okay. Now when process P3 comes, the size of this is 10 kilobytes. So again, it doesn't scans from the beginning, but it starts from scanning here itself. Okay, and it starts scanning from here itself. Now assume that, I'm just doing some change. We assume that when process P3, when job, we are tying as job. Okay. No, it's partition actually. Yeah, you're right. Partition P2, P3 partitions. Okay. When job J3 comes, and assume that we are assuming that there is no job sitting in partition P1, and the last allocated block is this. Then here we can differentiate between first fit and next fit. First fit and next fit. Now using first fit, if this job J3 comes 10 kilobytes and assume that this is empty. Okay, assume that this is empty. If this is empty, the last allocated block. Now first fit will start scanning from the beginning, irrespective of what is the last allocated block. It goes to up and scans and sees that there is empty, and it allocates partition P1. But so partition P1 will be allocated job J3. But whereas using next fit, the last allocated block was 200. Now what happens? It doesn't scans from the beginning, but it starts scanning from here. So it will check and allocates partition P3 for job J3. So that is the difference between these two algorithms. Both functionality is same, but the starting point is different, because of which job 3 is sitting in first fit in partition P1, but in next fit job 3 is sitting in partition P3. Okay. So here of course job 3, now the pointer will be pointing here now. Okay. So then again comes job J4, again also it is not possible to accommodate. Now when you see here first fit and best next fit algorithms, this is actually next fit. those both of us gives us the same output here, because the starting point for both of them was same here. Okay, but when I have taken a situation and assumption that if it is empty, then it gives us different scenario. Now we'll see best fit. Now in best fit, always it ensures that that partition will be allocated after loading a process or job into the partition. It should leave less number of internal fragmentation. Now keeping that in mind, let's see what happens. When first job J1 comes, okay, it is of 20 kilobytes. If 20 is allocated here, then internal fragmentation will be 10. Here it will be more. Here it cannot be accommodated. The choice is either it can sit in process P in partition P1 or in partition P4. Okay, so we resolve it on FCFS. Okay, what partition comes first, we'll allocate it. So assume that job 1 is sitting here. Okay, when job 1 is sitting here, then internal fragmentation is 30 minus 20 plus. When job J2 comes, again it is size of this job is 30 kilobytes. It will not be accommodated here, because here it cannot be accommodated because it is not possible. It cannot accommodate because the internal fragmentation will be more. But here the internal fragmentation is less, so that's why job J2 will sit here, and it leaves the internal fragmentation of 0. Okay. Then next, when job J3 comes, okay, it will not be accommodated here because it leaves a lot of internal fragmentation, but it will be accommodated here. So J3 can be accommodated here. When J3 is accommodated here, so then internal fragmentation is 16 minus 10. Then comes a job J5. Now the size of J5 is 100 kilobytes. Then J5 will be allocated because there is no other choice to scan for. Okay, so now here the degree of multiprogramming has been increased. Earlier, in the best fit proves to be best here in this case, because 4 number of processes have been loaded here according to this algorithm. The degree of multiprogramming has been increased. Now let us see what is the internal fragmentation. So internal fragmentation is 10 plus 6, which is only 16, but in earlier cases we have got 216, and external fragmentation in this case it is 0, so total fragmentation is only 16 kilobytes. So for this inputs, it has been proved that the best fit algorithm is good here. But because we don't have any partition left, okay, we cannot accommodate it. Suppose that after some time, if job J1 has got completed, but still it is not possible using best fit for this process to allocate this job. Okay, now assume that after some time, again, if job J5 has been completed, now it is possible for J5 to sit here. It is possible for J5 to sit here. Now in this case, suppose if J4 is sitting here, okay, and J5 cannot be accommodated here, in that situation external fragmentation would be 30, okay, and but it cannot be accommodated here. When suppose if it has been vacated, then job J5 can sit here. Okay. So it depends upon how these jobs gets completed and which partition is available. Among all those partitions, a smart decision will be taken depending upon these algorithms. Okay. Now there is third memory partition technique, which is called dynamic memory management or dynamic partitioning technique. This is very good technique actually. Let us see how this technique works. We saw single partition technique, multiple memory management partition techniques. Here we saw MVT, MFT, and MVT, and dynamic memory partitioning. Dynamic memory. Now, what is the advantage of this scheme is, here the size of the partition is not fixed, or neither the size of the partition is fixed nor the number of partitions are fixed. Okay, neither size of the partition is fixed.